Hi everyone, so today we are going to talk about the laws of your exponents. So on page 141, at the very top, we have this very nice summary of our rules when it comes to dealing with exponents. Now there are two parts to your exponents. You have your base and your exponent. So in this case, if we look at law 1, our a is the base, our m is the exponent. Now, what law 1 is saying is if you are multiplying two values that have the same base, in this case a and a, then whatever the exponents are, you can just add them together. Now, you have done this before. If you have x squared times x, well, that x has an invisible 1 for the exponent, so 2 plus 1 is going to give us x cubed of 3. And then for law 2, we have the opposite case. We have two values with the same base, and instead of adding, we are going to be subtracting. So again, if I take that x squared and divide by x, that x is to the power of 1, so we're going to take that 2 minus 1 and just get another x to the power of 1 back. Now with law 3, here it's basically distributing the exponent. We have two values, a times b, and they're going to multiply together, but be risen to the power of m. You can take that m and distribute it to a, give it a that exponent, and then give b that exponent, and as we see here, we get a to the power of m times b to the power of m. And then we are on law 4, same thing, and instead of multiplication, we have division. You're going to take that m and give it to both the a and the b. Now, the crucial exception is when b is equal to 0, because if you had b equal to 0, then, well, you're going to be dividing by 0, and we can't have that. Law 5, we have a to the power of m, and all of that is raised to the power of m. Now, whenever you're in this situation, basically just take that n, multiply it with the n. It is not m to the power of n or anything like that. It's just a times n, as we see here. Now, law 6 is probably the easiest rule. If you have anything to the power of 0, it is 1, with the exception of 0. So you can have 2 to the power of 0, it is 1. If you have 100 to the power of 0, it is 1. It does not matter what a is, again, except for 0. It's going to come out to be 1. So here we have some example problems. Now, if we look at the first one, we have 3 times x squared times y, and all of that is being squared. So using that third law, we're going to take this 2 and distribute to each term. So we're going to have 3 to the power of 2 times x to the power of 2, but it's already raised to the power of 2, so we're going to raise all that to the power of 2. And then times y to the power of 2. So let's break this down to each term. We have 3 squared, all that's just 9. And then we have x squared squared. Well, we need to keep in mind law 5. We're going to take that 2 and multiply it with the inside 2. And that's going to give us 2 times 2 is 4. And then finally, it's just y squared. Now notice how, since we have an x to the power of 4 and a y to the power of 2, we can't just add them like law 1 says, because they are different bases. So if they are different bases, you cannot combine them. All right, on to the next one. Here, just like before, we can use our law 5, take that 3, bring it inwards. We're going to have 3 times 2 is 6, so it's going to be negative 2 to the power of 6. And negative 2 to the power of 6 is going to have to be, we're going to have to break it down to 2 parts. So we have this negative sign and this 2. So we can make it negative 1 to the power of 6 times 2 to the power of 6, just like we had with law 3. Well, we have a negative 1 to the even power. Excuse me. A negative to an even power just becomes positive. So it's just going to be positive 1 times 2 to the power of 6. If you plug that into your calculator, you get 64. So in the end, it's just positive 64 or 64. All right, then we'll move on to number 3. So for number 3, we have 12a to the power of 7 divided by negative 4 over a cubed. Here, we can break it down as 12 over negative 4 times our a to the power of 7 over a cubed. Now this a divided by 7 over a cubed, this is pretty much our law 2. We're going to take this 7, subtract the 3, and we're going to get a to the power of 4. Now this 12 divided by negative 4, as we should know, is going to be negative 3. So in the end, we have negative 3 times a to the power of negative 4, or just negative 3a to the power of 4. Okay, on to number 4. Here, it's basically just distribution. We're going to take this xy squared and distribute to both terms. So we're going to have 3x squared times our x, y squared, and then plus our 2y squared plus x, not plus, times our x, y squared. Now, using what we learned from law 1, we have this x squared times x, just like I showed you all earlier. It's going to be 2 plus 1, which is going to be x cubed, and then our y squared. And then over here, we have 2y squared times xy squared. And just as before, we can take this y squared and add up the exponents. So we're going to have 2 plus 2 is y to the power of 4, and then our x. Now, with number 5, well, first thing you should notice is this 0. With this 0, we're probably going to be using law 6. Now, if we look in our parentheses, we have r cubed s to the power of 5. I don't see a 0. So this is going to equal 1, but we still have to be careful about those variables, because while they might not have a 0, those variables can be any number, including 0. So we're going to have to say r does not equal 0 and s does not equal 0. All right. Then we have 4 to the power of y plus 2 times 4 to the power of 6. Now this is where we have to keep our same bases in mind. We have a 4 for our base on our first term, 4 for the base in the second term. this means we can combine them. If they were different numbers, then we couldn't combine them. We have, using law of 1, y plus 2, and we're going to add the 6. So we're going to have 4 to the power of y plus 2 plus 6, which is going to equal 4 to the power of y plus 8. All right. And so last one for this group, we have this 7 and, number 7, a to the power of 4 divided by b. It's being raised to the power of 2. And then we have this a squared b squared to the power of 3. For this first group, we're going to use law of 3. For the second, we're going to use law of 4. For the second group, we're going to use law of 3. Basically, they're both saying we're going to distribute our exponents to both terms. So we're going to take the 2, multiply both exponents, and then we're going to have our 3 and distribute to both exponents. So this will become our a to the power of 4 to the power of 2 divided by b to the power of 2. And all of that is being multiplied by a to the power of 2 to the power of 3 times b to the power of 2. To the power of 3. Now, let's go ahead and multiply out our exponents. So this will become a to the power of 8, because 4 times 2 is 8, over our b squared. And then we have a to the power of 2 times 3, which is going to be a to the power of 6. And then we have b to the power of 2 to the power of 3, which is going to be b to the power of 6. Now, with our a's, we have the same base, and they are multiplying, so we're going to add the exponents. But for our b's, we're going to divide the exponent. So we're dividing, so we're going to subtract the exponents. So we're going to have a to the power of 8 plus 6, which is 14. And then we have b to the power of 6 minus 2, which is going to be b to the power of 4. So this is our final answer. Okay, here we have some problem with some numbers. Now, before beginning number 1, let's ask ourselves, is this minus sign going to be used with the exponent that we have here? Now, unless you see any parentheses around your number and the minus sign, then assume that the minus sign is separate. So what we're going to assume here is that we have negative of 4 squared. Now that we know the 4 squared, what we can do is just go ahead and square it. 4 squared is 16. So we're going to have 16 and then tack on that negative sign. So that's the first one. And then if we look below, we have 2 times 8 to the power of negative 2. You have a couple ways of going about this. You could do like we did on the previous page and distribute that negative 2. Or, since these are two numbers that we know the values of, what we can do is just take that 2 times 8, multiply them together, we get 16, and it's going to be to the power of negative 2. Now, it's probably been a while since you've dealt with a negative sign in the exponent, but all that means is you're going to be taking the reciprocal. So instead of 16 squared, we're going to have 1 over 16 squared. Now, 16 squared is 256, So our final answer is going to be 1 over 256. If you ever have a question that tells you to get rid of any negative exponents or leave all your answer in all positive exponents, make sure you take that minus sign and make it a reciprocal. Don't just leave it in the exponent. Now here we have 2 more problems. Go ahead and take a moment and try these yourself. So for the first one, what we notice is we have a 3x squared and a 6x squared. And what we get is 2 numbers that we can add together, and we get 9x squared up top. After we get that 9x squared, we can use our laws that we saw on the previous page to combine the x squared's coefficients, giving us the x squared minus -2, and -2 plus 2, 2 minus -2 is going to become 2 plus 2, which is 4. So that's what's happening here. As for the second one, if you haven't done it yet, take a moment and try it. As a hint, try to get everything to the same base. All right, so for this one, what we notice is we have 125, 25, and 5. In order to get the same base, what we can do is take our 25 and make it a 5 squared. Now, it might not be obvious what 125 is, but if you remember your cubes, 5 cubed is 125. Now, we're going to use our fifth law to take that -3, multiply with the 3 from our 5 cubed, and we get 5 to the power of -9. After that, we can combine all of our exponents. So as we see here, we have 5 minus 9 plus 2 minus -8. And if you combine that all together, your exponent's just going to be 1. If your exponent's 1, you don't really have to write it. So our final answer is just 5. All right, so let's look at number 32. With this one, we have 2 values that have different bases. Well, we can't do the trick of getting a common base with these, but what we can do is, since they are numbers, is go ahead and combine them. Before I combine them, I'm going to go ahead and rewrite it as, since this is a reciprocal, 1 over 3 squared, which is 9, and 1 over 4 squared, which is 16. And this is to the power of -1/2. Now, what is 1/9 plus 1/16? Well, we're going to have to use what we learned from our fractions, get a common denominator, and then add them together. When you do that, what you get is 25 over 144. And this, we're going to have to the power of -1/2. Well, that negative sign in the exponent means that we're going to take the reciprocal, so we're just going to flip it across the fraction bar, giving us 144 over 25. And that 1/2, you may not remember this, means we are going to be taking the square root. So we're taking the square root of 144 over 25. Now the square root of 144 is 12, and the square root of 25 is 5. Well, there's nothing else to do, so this is our final answer. Now, after 32, we have 33, and it is a very similar problem. Go ahead and try it out yourself. So with 33, we could approach it this way, just like the last one, where we convert it to fractions. We get 1/9 times 1/16 is 1/44. And then we're going to take the square root of the reciprocal, so square root of 144, and get 12. But we could have also used our rules from before. So if we distribute that negative 1/2 to both terms, what we get is the negative 2's that were in the exponents cancel out with the 1/2, giving us just 3 times 4, and 3 times 4 is 12. So there are a couple options, or a couple different paths that you can go with these. Now, here's a couple more to try out, and then I'll show you the answers. So for number 35, we have all of our bases with a 9. We can combine these together as a single exponent, but with these exponents, we have fractions. So we can't just simply add them together. We have to get a common base. So in this case, 12, or not base, denominator. Get a common denominator of 12. When you add those together, you get 6/12, or 1/2. And 9 to the power of 1/2, that is the square root of 9, or 3. And take a look at number 39. So with 39, we can break up our rational into two fractions. We have x to the power of 1/2 over x to the power of negative 1/2. And we're subtracting 2 times x to the power of negative 1/2 over x to the power of negative 1/2. Well, for our first rational, we're going to get our exponents combined to just equal 1. This gives us x. However, for our second rational, the exponents are going to cancel out, leaving us just with the 2. So in the end, we have just x minus 2. For this last section, you're just asked to solve your equations. So instead of simplifying, we are actually trying to find what x is equal to. What we can do is use our common bases, like we showed on some previous problems, and then solve using our other exponent rules. With the number 41, we have 8 to the power of x plus 2 to the power of 6. Now, in order to get a common base, I notice that I have 8, which is 2 to the power of 3, or 2 cubed. And that is raised to the power of x is equal to our 2 to the power of 6. I can go ahead and multiply my exponents. I get 2 to the power of 3x is equal to 2 to the power of 6. So now we're in a situation where we have both sides in the same form of 2 to the power of something. Our exponents are the only thing that's changing, so that's the only thing we'll focus on. We're going to have 3x equal to 6. Well, 3x is equal to 6 means that our x is equal to 2. So with these, just take the step of get a common base, use your exponents rules to simplify. Once everything is your base to the power of something is equal to your base to the power of something else, just drop the bases, focus on your exponents. So take a moment and have a look at number 47 and try it yourself. So with 47, what you can do is instead of trying to find a common base immediately, we basically just have our 8x to the power of -3 is equal to 64. Instead of trying to distribute that 3 and try to figure out what 8 to the power of 3 is, what we can do is take the cube root of 64. The cube root of 64 is 4. And then we're going to go ahead and give that 4 our exponent of -1. This gives us 8x is equal to 1/4. And when you solve for x, you'll divide both sides by 8 and get 1 over 32. Now take a moment and try something similar with number 48. So with number 48, while you can do the same trick, since the 8 is not in the same parentheses as our x, we're going to have to move it away from our x before we do anything with it. So we divide both sides by 8, we get our x to the power of -3 is equal to 8. And then, just like before, we can cube root it. The cube root of 8 is 2, so x to the power of -1 is equal to 2. And then from there, we're just going to find the reciprocal. So x is equal to 1/2. All right, so that is it. I hope y'all have a great rest of your day.